Rock here, Simpson Math. In this lesson, we're just going to look at reviewing some algebra, but we're going to put trig expressions in algebra. So we're doing some basic algebra with trig expressions. So having something like maybe cosine of theta times sine of theta plus sine of theta all over sine of theta. Okay, corrected my theta there, that was weird. Okay, so we want to be able to simplify algebraic expressions like this, even though they have trig expressions inside them. This particular one, we could decompose the fraction, or we could factor out the greatest common factor in the numerator. So one way to handle this would be to factor out this sign in the numerator. Sine of theta times cos of theta gives me the product of sine cos, and sine of theta times 1 gives me sine of theta. And I still have this denominator sine of theta, and then you can reduce the common factor, and you have cos of theta plus 1. So we simplified this expression. Now, of course, this is not equal to that anytime that sine would be equal to 0, because sine of 0 would be undefined. So provided that sine of theta does not equal 0, these two expressions are equal. And we just want to be able to do this kind of simple algebraic manipulation and simplification when there's trig expressions. And we're going to do this type of problem another way as well, where instead of factoring out the common factor, we decompose the fractions. But let's move over here to this one. So this problem says factor. So we have a basic algebraic expression here. We just have a product minus another product, and we want to factor it. And we notice a common factor. The common factor is cosecant x. So we'll take that common factor out. Okay, so the common factor got factored out, and that left us a tan squared. Wait, I didn't take the greatest common factor. Oh, silly me. The greatest common factor would have been cosecant times tangent, because look, there's still a tangent, so I'll do that next. I'll take out the cosecant and a tangent. Notice they both have a tangent. Here's a tangent here and a tangent here. So I could have done that in one step. And I get tangent, because tangent times tangent is tangent squared minus 1. So there I factored at the greatest common factor. Now here's one where we can, it asks us to combine like terms. We want to combine like terms. We can see that, can we? Yeah, that's in the screen. Okay. We want to combine like terms. Well, to do that, we're going to have to, we can't combine means to add and subtract, but we can't subtract until we've done this multiplication. But notice we have the rules for difference of squares. Remember, the difference of squares, if you have a plus b times a minus b, you just get the square of a and the square of b difference. A squared minus b squared. Well, that's what we have here. So I'm going to get sine squared minus, I don't know why it keeps correcting me, minus cos squared. But this minus is in front, so we need that. We need to hang on to those parentheses. They're going to be real important, because in order to combine, we're going to have to subtract. We're going to have to distribute this negative. So I have cos squared, that's supposed to be a theta, minus sine squared theta, plus, because of this double negative, plus cos squared theta. And so if I combine like terms, cos squared and cos squared is 2 cos squared theta, and then I still have the minus sine squared theta. And I don't know why it keeps changing that. And so we combine like terms there. So you have to remember your multiplication rules. Here's a problem where we reduce. It asks us to reduce, but to reduce we want to factor. So I'm going to try to factor the top. So the bottom's going to be sine x take away 2. But my numerator is going to factor, I hope. If this was, let's write this 2w squared minus 3w minus 2, you could factor it, right? You would say, let's see, it'd be 2w and w times 2w is 2w squared. And then to get 2 on the last, I would need like a 1 and a 2. Let's see, would that work? That'd be 4 and 1. 4 and 1 have a difference of 3. So if I made the 4w negative, so if I put a negative here, 2w times a negative 2 would be a negative 2w. And then make this a positive 1, so positive 1 times a negative 2 is a negative 2. And so, and then this 1w combined with that negative 4w gives me negative 3w. So we're going to do the exact same thing, but we're treating this sign as w. So we're going to have 2 sine x and sine x. Then we're going to have our 1 and our 2. We figure out where the signs go, and they were a negative and a plus. And there we factored it. Oh, look, we'll be able to reduce now because this is a common factor with this, and it leaves me just 2 sine x plus 1, provided the sine of x is a 2, which it never is, so we're safe there. And one more problem as an example. Now we could do this one like we did the very first one. I could factor out the common factor of tan squared. But instead, I'm going to decompose the fraction, meaning I'm going to recognize that this whole numerator is over this denominator. So I can write this term over the denominator, and I can write that term over the denominator. We call this step in my class walking like the Egyptian, and this is the icon for it. Okay? So walking like the Egyptian is just breaking it up into 2 fractions. Now, here we have tangent cubed over tangent squared, so that's going to be tangent, because we have 3 of something over 2 of something, so 2 of them cancel out. And then here, these both cancel, both of them cancel with those 2, and leave me just cotangent of x. And so I have tangent plus cotangent when I simplify. So there are some examples of using basic algebra with trigonometric expressions, and that's what we're going to do in this lesson. Math Made Simple, Simpson Math.